Okay, we are going to start Cambridge IGCSE, and this is a paper from the session May-June 2025, and the code is 0606/11, and this paper is the non-calculator. Let's move to the question number 1. It is given that PQ is equals to -3, 7, and the 4PR is equals to -2, 8. Find the value of RQ. Okay, we should know that PQ is equals to Q minus P. So first we find the PR. PR is equals to 1 over 4 -2 8, and this one is equals to the -2 over 4 and 8 over 4, which is equals to the -1/2 and 2. This is the PR, which is equals to the R minus P. Secondly, we have the PQ, which is equals to the -3, 7, which is equals to the Q minus P. Okay, now we need to find the RQ, which is equals to the Q minus R. Okay, this is the Q minus P and this is the R minus P. So we get the value of R. Here R is equals to the P plus PR. So this is the R. And this one is equals to the PQ. And further solving, we will have Q is equals to P plus PQ. Okay, we need to find the value of RQ, which is equals to Q minus R. And Q is equals to P plus PQ, minus R is P plus RQ, P plus PR. Further solving, we will have P plus PQ minus P minus PR. So P will be cancelled out and RQ is equals to the PQ minus PR. And we have the information of PQ. PQ is equals to the -3, 7. And we have the PR. PR is equals to this one, minus 1 over 2, 2. Further solving, we will have -3 minus, this one is negative, so negative half and 7 minus 2. So RQ is equals to the -5 over 2 and this one will be 5. Okay, let's move to the part B. The vector A, B, C are such that A is equals to alpha I plus B 6j and B is equals to 4I plus beta j and C is equals to 2 alpha plus 5 beta I plus 20j. Where A and alpha and beta are scalar, given that C is equals to 3A minus 2B, find the value of alpha and beta. So it is given that C is equals to 3 times A minus 2 times B. C is 3A minus 2B and C is equals to 2 alpha plus 5 beta I plus 20j is equals to 3 times A, which is alpha I plus 6j minus 2 times B means B is 4I plus beta j. So we will have 2 alpha plus 5 beta I plus 20j is equals to 3 alpha I plus 3 times 6 is 18j minus 2 times 4 is 8I minus 2 beta j. Further solving, we will have 3 alpha minus 8I plus 18 minus 2 beta j. So in left side 2 plus 5 beta I is equal to 20 plus 20 G. Comparing the values, comparing 2 alpha plus 5 beta is equal to 3 alpha minus 8. For the terms of G, we will have 20 is equal to 18 minus 2 beta. Further solving, we will have 2 beta is equal to 18 minus 20 and beta will be equal to negative 2. 2 times beta is negative 2 and beta is equal to negative 1. So this is the scalable value of beta. Now, in this case, we will have 3 alpha minus 2 alpha minus 5 beta minus 8 equal to 0. So we will have alpha minus 5 beta minus 8 equal to 0. Alpha is equal to 8 plus 5 beta and beta is negative 1. So we will plug 8 plus 5 times negative 1 and so alpha is equal to. So we have calculated the alpha and beta, which is alpha is 3 and beta is negative 1. So these are the values which was required and we have calculated. Now let's move to the question number 2. Solve the following inequality. Okay, we have the inequality which is 3 minus x times 5x plus 8 is less than and equals to 9 minus 33x. So first we will multiply here. 3 times 5x is 15x plus 24 minus 5x square minus 8x and switching left right terms on the left side we will have minus 9 and plus 3x and this one will be greater than and equal to 0. Solving further we will have minus 5x square 8x and 7x plus so this will be 10x and this one will be equal to the plus 15 which is greater than and equal to 0. Okay, this is the negative sign. If we multiply this inequality with negative 1, the sign of the inequality will be changed. So it will be 5x square minus 10x minus 15 with less than and equal to 0. Taking 5 common, we will have x square minus 2x minus 3 is less than and equal to 0 and this will be equal to x square minus 2x minus 3 less than and equal to 0. Okay, this is the quadratic equation. We will solve it first. X square minus 2x minus 3 equal to 0 and this one is equals to the this is the quadratic equation. We can solve it by factorization. So x square minus 3x plus x minus 3 equal to 0 and this will be x is common, so x minus 3 plus 1 common and x minus 3 equal to 0. So x plus 1 times x minus 3 is equal to 0. So we have the two factors which is x plus 1 equal to 0 and on the other side we have x minus 3 equal to 0. Here we have x is equal to negative 1 and here x is equal to 3. So this quadratic function is less than and equal to negative 1. So we can see that x plus 1 times x minus 3 is less than and equal to 0. So in this case, we can say that x is less than and equal to 3 and greater than and equal to 1, negative 1. So this is the solution of given inequality. Okay, let's move to the question number 3. Point A has the coordinate 3, 1 and circle has the equation x minus 4 whole square plus y minus 3 whole square is equal to 5. Show that A lies on the circumference of the circle. Okay, first we should know that x minus h whole square plus x minus k whole square is equal to r square. This is the general equation of the circle and here r is the radius and h comma k is the center. So this is the circle equation. And if a point given which is 3 comma negative and is the is on lies on the circumference of the circle, then this point should satisfy this equation. So we will plug this coordinates in the circle equation. So plugging 3 comma negative 1 in circle equation. So x is coordinate is 3, so this will be 3 minus 4 whole square plus y plus 3 whole square. So y is negative 1 plus 3 whole square equals to 5. So 3 minus 4 is 1, 1 negative 1 to the 1 square is 1 plus 2 square is 4 is equal to 5. So we can say that 5 equals to 5. So this shows that 3 comma negative 1 lies on circumference. Let's move to the part B. Given that the AB is the diameter of the circle, find the coordinate of the B. Okay, this is the circle and this is the center which is H and K. So in this case, H is 4 and K is negative 3. So we can say that center is 4 comma negative 3. So this one is 4 comma negative 3. And it is given that AB are the diameter. So this one is A and this one is B, and coordinates of the A is 3 comma negative 1. And we need to find the coordinate of the B. So this is the center. So we can say that C, which is center of circle, is the midpoint of diameter AB. So we know that midpoint is equals to the x1 plus x2 over 2 comma y1 plus y2 over 2. And in this case, midpoint is E, which is 4 comma negative 3, and the A is equals to the x1 comma y1, which is equals to the 3 comma negative 1, and B is x2 comma y2, which is unknown. So plugging these values in the equation in the midpoint, so we will have C, which is 4 comma negative 3 equals to the x1 is 3 plus x2 over 2 comma y1 plus y2 means negative 1 plus y2 over 2. Equating x coordinate and y coordinate, we will have 4 is equals to 3 plus x2 over 2, and on the other side we will have negative 1 plus y2 over 2 is equals to negative. In this case, x2 is equals to 8 minus 3 and x2 is equals to 5. And solving this one, we will have y2 which is equals to negative 6 plus 1 which is equals to negative 5. So y2 is equals to negative 5. So B coordinate will be equals to the x2 comma y2, which is equals to the 5 comma negative 5. So we have calculated the coordinate of the B. Now let's move to the part C. Find the equation of the tangent to the circle. Okay, we have the circle, we have the point A, and we need to find the equation of this tangent. Okay, and we have the center which is equals to the 4 comma 3, and we have the information of A which is 3 comma negative 1. Okay, If we want to find the equation of the tangent to the circle at A, we need the slope point form. So slope point form is y minus y1 is equals to mx minus x1, and m is the slope of tangent, and x1 y1 is the point A which is given, which is 3 comma negative 1. So we need to find the slope of the tangent. And first concept you should know that if we know the slope of the AC, so the slope of tangent will be perpendicular to the AC. So we can say that slope of tangent A at A is perpendicular to the slope of AC. So if we can find slope of AC, we can find slope of tangent at A. First, we find slope of AC, and we know that slope of AC is y2 minus y1 over x2 minus x1, and in this case A is equals to x1 y1 which is equals to 3 comma negative 1, and the B is the x2 comma y2 which is equals to the 4 comma negative 3. So plugging these two values in the slope equation, we will have negative 3 minus negative 1 over 4 minus 3, and this one is equals to the negative 3 plus 1 over 1 which is equals to negative 2. Okay, now as we know that tangent is perpendicular to the AC, so slope of tangent times slope of AC is equals to negative 1, and in this case slope of tangent is equals to 1 over negative 1 over MAC, and this one is equals to negative 1 over negative 2 which is equals to 1 over 2. So we have the information of the MT which is the slope of tangent. We also have the information of point E which is 3 comma negative 1. Using these two information, we can find the equation of the tangent. Y minus y1 is equals to mt times x minus x1, and in this case y minus y1 is negative 1 is equal to mt is 1 over 2 times x minus 3. So we have y plus 1 equals to 1 over 2 times x minus 3. So this is the equation of the tangent at point A. Okay, let's move to the question number 4. Solve the equation x to the power of 1 by 3 minus x to the power of 1 by 6 is equals to 2. Okay, we suppose that x to the power of 1 by 6 is equals to y. Let So y square is equals to x to the power of 1 by 6 square, which is equals to the x to the power of 1 by 3. So we can write this equation as y square minus y equals to 2, and this equation is equals to y square minus y minus 2 equal to 0. This is the quadratic equation and can be solved by using factorization. So y square minus 2y plus y minus 2 equal to 0, and this one is equals to y common, y minus 2 plus 1 common, y minus 2 equal to 0. So this one is equals to y plus 1 times y plus minus 2 equal to 0. We have the two factors equating each with 0. Y plus 1 is equal to 0. So y is equals to negative 1. On the other side, y minus 2 equal to 0 and y is equals to 2. We know that y is equals to x to the power of 1 by 6. When we plug y is equal to negative 1 in this equation, we will have x to the power of 1 by 6 equals to negative 1. So x to the power of 1 by 6 is equal to negative 1, which may have two values. X may be have negative value and positive value. Should be positive to have real solution. So this value can have real solution and imaginary solution both. So we are ignoring it. On the other side, y is equal to 2. So we can say that x to the power of 1 by 6 is equal to 2. Taking 6 power both sides, we will have x is equal to 2 to the power of 6, which is 64. So we have the solution x is equal to 6. Now let's move to the part B. Solve the simultaneous equation. So we have the equation. This one is LG means log 10 of x plus 2y equal to 0. And we have another equation which is x square plus 4xy plus y equal to 1. The basic information of the log says that x is equal to a to the power of n, and this expression can be written as, or this equation can be written as log a x is equals to n, and this equation can be written as log tan x plus 2y is equals to 0, and this one is equals to the x plus 2y equals to 10 to the power of 0. So this equation can be written as x plus 2y equals to 1. And we need to solve this equation and this equation simultaneously. So first we find the value of x, which is equals to 1 minus 2y, and plug in equation 1. So we have 1 minus 2y square whole square plus 4 times x means 1 minus 2y times y plus y equals to 1. So solving this, we will have 1 minus 4y plus 4y square plus 4y minus 8y square plus y equal to 1. This one will be cancelled out. This 4y positive 4y and negative 4y is cancelled out. So we will have negative 4y square plus y equal to 0. Taking y common, we will have negative 4y plus 1 equal to 0. So we have the two factor, one is y is equal to 0, and second one is negative 4y plus 1 equal to 0, and this one is equals to y is equal to 1 over 4. So we have the y coordinates. Now plug this y coordinates in equation 2 to have the x coordinates. So we have x plus 2y equals to 1. So when we plug y is equal to 0, we will have x plus 2 times 0 is equal to 1 and x is equal to 1. Now plug y is equal to 1 by 4, we will have x plus 2 times 1 by 4 equals to 1, and this one is equal to x plus 1 over 2 is equal to 1, and x is equal to 1 minus 1 over 2, which is equal to 1 by 2. So x is equal to 1 by 2. So coordinates are 1 comma 0, this one and this one, and this one and this one. So we will say that 1 by 2 comma 1 by 4. So these are the solution. This is the required solution.